Hi everyone. What I'm going to do in this video is go over a couple of these derivations again. I put them in the notes from September 28th and went over them in class today, but let me just go over them again to reinforce it. Okay, so the first thing we'll look at is the derivative of a to the x. How do we get that? Well, what we can do is take a look at a. What is a? A is e to the natural log of a, correct? So a to the x is e to the natural log of a raised to x. Okay, now if you remember your power rules, if you have k raised to m raised to r, what will it be? It'll be k raised to m times r. Okay, so applying this little rule, we get that this a to the x is e raised to log a times x. Okay, and now we want the derivative of a to the x, so let's differentiate both sides with respect to x. Okay, so you have d dx of a to the x. That's the formula we want. That is the same as d dx of e raised to log a times x. Okay, what is e raised to log a times x? Well, this over here, that's just a number, right? It's just a constant. So differentiating e to log ax is just like differentiating e to the negative 5x. What's the derivative of e to the negative 5x? It's e to the negative 5x times the derivative of negative 5x. So you throw in a negative 5 in front. So just like that, the derivative of e to the log a times x will be e raised to log a times x times the derivative of log a times x, which is log a. Okay? All right. Now let's simplify this again. We already know that e raised to log a times x, well, once again, just reversing what we had before, you can think of that as e raised to log a raised to x, and e raised to log a is just a, so this is a raised to x. Anyway, you already know from before that that was just a to the x. Okay? So that gives you the formula that the derivative of a to the x, or you can also write a raised to x prime, is a raised to x, and you have to multiply it by log a. Okay? And of course, you already know the derivative of e to the x is e to the x. And, that agrees with this. If a is e, what are you going to have? You do have derivative of x is log e times e to the x, but log e is 1. But, we're not using this to derive this formula because we did use this in the step right here. Okay? So obviously we can't use it in the derivation and then derive it from this. But anyway, I just wanted to show you it agrees with the old formula. Okay? All right. Well, let me just erase this so it doesn't look like I'm deriving that from this. Okay. So, example. Let's say you want to differentiate 7 raised to 3x squared, okay, minus 5. Let's do all that. Okay, well, what's the derivative? It is 7, which is like your a, raised to some function in x. So we will use the chain rule. You'll have 7 raised to that function, okay? But you have to multiply by the derivative of that function, which is 6x minus 0. But don't forget, we have to throw in the log 7 in front, okay? So it is log 7 times 6x times 7 raised to 3x squared minus 5. Okay, so that was just a simple example of that. Maybe not the simplest, one step up, which is using the formula along with the chain rule. Okay, the next thing we will do is look at the derivative of log x to a different base. Okay, and what is this? Okay. All right, well, first, once again, we're going to look at what we're differentiating and rewrite it. Well, this, if you remember, this is natural log of x over natural log of b. Okay, so the derivative of log x with base b is the derivative of this quotient. Okay, well, I said the word quotient, but you don't need to use the quotient rule. Why? Because this is just a constant. Okay, so you can think of it like this. Log x times 1 over log b, you want to differentiate that. This is a constant, so it comes out. And you have the derivative of natural log of x, which is just 1 over x. Okay? So that's your formula for the derivative of log x with a different base. You can write it in the prime form or the ddx form. And in this formula, you have to divide by the natural log of b or multiply by 1 over log b. And it is this. Okay? So let's take an example. Let's say you want to, let's say you have to differentiate log to base 3 of sine squared 2x. Okay, no big deal. Don't need to fret that I have a square and a 2x. That doesn't matter. Okay, what do we have? Well, you have log to a different base of some function in x. So the formula says you should have 1 over log 3, okay, times 1 over whatever you're taking the log of. If it's x, it's just 1 over x. But it wasn't just x, it's a function in x. So we need to multiply by the derivative of that. Okay, so keep going. What is the derivative of this? Well, you think of it as sine 2x squared prime. Okay, so it'll be 2 sine 2x times raised to 1 times the derivative of sine 2x. What's the derivative of sine 2x? It's cosine 2x. It's not just cosine x, sine x over here. It's sine 2x. So you need to then multiply it by the derivative of 2x, which is 2. Okay? So let me just write down what I was saying there. That is sine 2x squared prime. Okay? So this whole long thing, that's the answer. Oh, and this was a 1, not a prime. So let's just make sure it looks like a 1. Okay, put it all together and you have 4 over log 3, okay, times sine 2x times cosine 2x over sine squared 2x, okay, and as long as sine 2x is not 0, you could even cancel it and end up with cosine 2x over sine 2x, correct? If you did cancel one of these. Okay, well, that's curious. Here's something else to note with the same example. If you, instead of doing it this way, noted that you have log of base 3 of a square and use the log rules. So you have log base 3 of sine squared 2x. Okay, so what is that? Log base 3 of sine 2x squared. Okay, you're not squaring the 2x, you're squaring the sine. Okay, maybe we should use a different parentheses. Okay, just to make it clear what's being squared. Well, log to any base b of a to the r is r log to base b of a. So you can actually bring the power down. Okay, so you can bring this power down in front. Oh, so that's nice. So now let's differentiate. The 2 is just a constant. We want to differentiate this. It's log to a different base. So we have to throw in 1 over the natural log of that base. And then you have 1 over the inside. But that wasn't just x, so you need to put the derivative of that. What is that? That'll be cosine 2x. That's not just x, so once again, throw in the derivative of 2x, which is 2. Put it all together, and you have 4 over log 3 cosine 2x over sine 2x. Okay? So, you see it's the same answer. This was just simpler because we used the log rules. Okay. So I hope that made sense. Now, let's look at a couple of examples on implicit differentiation. But for that, I'll make a separate video so it's not too long to post, okay? So this was just log base b of x and a to the x derivations of the derivatives and a couple examples. Okay.